Today we are going to do section 7.4, so please turn to page 737 of your book and let's look at example 1. What we're going to do is last time in the previous section we talked about sine and cosine, various values for sine and cosine, and now we're going to do the same values but now it's for angles for tangent, cotangent, secant, and cosecant. That is the stuff over here. Remember there's sine, cosine, and then there's tangent, and these are the three main ones. Okay, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then there are three others that are sine, cosine, tangent, except flipped around, and they are not as significant, but we'll talk about them anyway because it's a tradition to let them tag along. Although they're not strictly speaking necessary, because all we need to do is just say 1 over sine, right, instead of cosecant. But anyway, let's look at example 1 on this page here. What are we doing? We have a point on the unit circle, and we're supposed to find what's the value of all 6 functions. Okay, so let's do that. The point which is on the unit circle is minus, I'll draw this thing out, and let me write it down here. So we have a point here, and this point is on the unit circle because if you take this squared, that would be 3 over 4, plus this squared would be 1 over 4. 3 over 4 plus 1 over 4 is 1. And so as a result, this length here is 1, and therefore it's on the unit circle, which means a circle that has a radius of 1 unit. But we're not going to draw that here. So here's the angle here. We have the angle always start at x-axis. Okay, this is the x-axis. It starts from the positive x-axis and you measure it all the way over there, and that is our angle. And so then to measure it, now we need to figure out what are the trigonometric values for these things. So first, let's do the sine of this angle. We'll call it, does it have a name? I think the book calls it t or something. I think it's upside down. Yep, t. All right, so this will be the angle t, and first let's calculate the sine of t. Sine of t would be equal to calculate the sine of an angle that looks like that, we do the reference angle. That is the actual angle it makes with the x-axis that's acute, that is less than 90 degrees. So we're considering this angle here, okay, in order to find sine of t. So what is the opposite of this angle? This is as 1/2 divided by hypotenuse. Okay, that is so the value of sine, which is opposite divided by hypotenuse, is equal to 1/2. Let's see, my marker seems to be passing out. Okay, and next, cosine of t will be equal to the adjacent, okay, over hypotenuse. Again, when we calculate this sine of a angle that looks like that, we are actually considering this is called a reference angle. That's all we think of. Okay, so this is the reference angle, and that's what we're considering. So the cosine of t is the adjacent over hypotenuse, which is minus square root of 3 over 2, and then divided by 1. Okay, this is sine of, everything is divided by 1 because this is, the triangle is on the unit circle. So so that's cosine of t. Continuing, tangent of t then equals to opposite divided by adjacent, which is 1/2 divided by, the opposite is 1/2, adjacent is the negative square root of 3 over 2. So that would be equal to divide by a fraction is the same as inverse and multiply. So we're doing 1/2 times, flip this thing around, okay? So that's square root of 3 over 2. That would be equal to, let's see, I forgot to flip it around. I was thinking this looks odd. That's because I did not flip it around right after I said let's flip it around. So again, let's flip this around so the 2 now is on top. So that would be 1 over square root of 3, and that's the tangent of t. And then, so now we have the three main ones. And what about the others? Now remember, cosecant is 1 over sine, that is flip sine around. So cosecant, CSC, we'll write it next to sine of t, is flip this around, which is just 2. And then this is, let's see, what is this thing? Yeah, that's the secant, which is 1 over cosine. So secant of t equals to, let's flip that around, that equals to 2 over square root of 3. And finally, cotangent is flipping tangent around. I will write it over here. Okay, so cotangent, which is of t, is going to be equal to, right here, flip this thing around, is square root of 3. So that is the answer for all our 6 angles. Sometimes, well, most of the time, you're required to rationalize or something the denominator because there's a radical sign here. So we'll do that by multiplying square root of 3 on top and bottom. So that will, this is a 2 here. What happened to my wipe? There. This was a 2, this. Okay, this was a 2, see, 2. We'll multiply top and bottom by square root of 3, and then this is the final answer. That doesn't do anything nowadays. This is left over from the good old days when we don't want radical signs in the denominator because there was no calculator to deal with it. Okay, this is much easier to deal with if you have to do division by hand. So that is why that is done. And we still do it because old habits die hard. So anyway, so that's the answer, and all this should be the answer for example 1. I will check to make sure I got everything right. Yeah, I think I forgot some of the negative signs. See, tangent is a positive 1/2 divided by, this is negative. So I have negative here, and then I lost it in between. So let's add a negative sign. And this thing, similar to that, you can also write it as square root of 3 over 3. All right, so that's better. Let me continue the check. The secant is also negative because cosine is negative, and secant is flipping cosine around, but it didn't say, but you're not supposed to lose the negative sign, just by flipping. So I forgot the negative sign. So there's that. Cosecant and then cotangent. Cotangent is also negative. That's because tangent is negative. I'm still missing the negative sign. What's with this? Okay. Cotangent is also negative. Okay, so now that I got all the negative signs made up, then we're good. So we're done with example 1. So next, let's look at example 2 on the following page, 738. Now example 2, it wants us to find the sine and cosine, etc. of pi over 6, which is 30 degrees, being that pi is 180 degrees. So we have this old triangle here, and we already did sine of pi over 6 and cosine of pi over 6 in the previous section. Sine of pi over 6, which is 30 degrees, is 1 over 2, okay, opposite over hypotenuse. Cosine for this, the same angle, will be square root of 3 over 2. Adjacent over hypotenuse. Tangent will be 1 over square root of 3. And then the cotangent, cosecant, and the secant will be flipping those 3 things over. So please do example 2 yourself with reference to this triangle here. And then we'll move on to the next page, page 739. On top of page 739, we have these angles that I show you here. Not just this triangle, but also this triangle, and all kinds of values for it. For example, let's consider tangent of 45 degrees. What's tangent of 45 degrees? From if you look at this triangle, tangent is opposite over adjacent. Okay, so right here, this is opposite of 45. This is adjacent of 45. So opposite divided by adjacent equals to 1. So tangent of 45 degrees, or pi over 4, equals to 1. That is just one of the several examples. Now, a couple of things I should mention, however, that the tangent of 90 degrees will show up doing something odd. I should first mention that the cosine of some of the zero values that I don't think I mentioned it that much. Okay, then yeah, let me see. Cosine, the 0 degrees and the 90 degrees, what that means. Now let's first consider the 0 degree angle. 0 degree angle means your thing is just laying flat here, it's not moving an inch. So what is the, and this is 1, okay? And so what is cosine of 0? Cosine of 0 is whatever length this is on the x-axis, because normally the cosine is just is the length here. Okay, this is the cosine on the side, cosine of t, where t is this thing, and then this thing is sine of t. So then cosine is whatever this length is. So when this angle is 0, the cosine is a full 1. And similarly, if the angle is clear up here, straight up, then the sine value will be 1. So sine of pi over 2 equals to 1, as you see in this chart here. Okay, sine, where it says sine of pi over 2 is 1 along the sine line. The question, and now the tangent is opposite is the opposite side divided by the adjacent side. Okay, now so when this is 0, when the opposite side is 0, then the tangent is just 0. So tangent of 0 is also 0. Now what happens when you go all the way up to 90 degrees? So then the opposite side is 1, but the adjacent side becomes 0. Then you get 1 divided by 0, and that is not defined because it's not possible to divide by 0. So we just call the tangent of 90 degrees is called undefined. In other words, we don't give it a value. Okay, we don't know what it is because you cannot divide by 0. And as a result of it, anytime that something is 0, then the functions that flip over is undefined. For example, sine of 0 is 0. Okay, sine of 0 degrees or radian is going to be equal to 0, which means cosecant, cosecant then equals to 1 over sine. Okay, you need sine flipping over around, which means 1 divided by 0, which is undefined. So that's why you notice cosecant of 0 in the chart here. Okay, the cosecant of 0, if you see in this chart, then it says cosecant of 0 is undefined right here. And similarly, cotangent of 0 is also undefined. That's because the tangent of 0 is 0. So anytime the function is 0, then is that other one that's defined by flipping it over is going to be undefined because you cannot divide by 0. And that would be the only reason. And anyway, so please finish this entire chart yourself. That is, confirm each value that the book is correct. Okay, and go over each one and see why the values are what they say. And it shouldn't take too long by using these two charts as reference, or just or when the line is completely vertical or completely horizontal. So that is that. And so next, let's look at example 3. Example 3 on the following page. I'm now at page 740. So example 3 on page 740, we're supposed to find all the tangent, sine, cosine, etc. of some angle called minus 5 pi over 6. Well, where's that? Now, minus pi measures down here, so it goes down this way. How far does it go? It goes, it doesn't make it to a whole pi. 5 pi over 6 is almost a full negative pi. If it was a full negative pi, it will go all the way up here. But being that it doesn't get all the way up there, so it's missing a little bit. How much is it missing? It's missing 1/6 pi. That is 30 degrees. So this angle is pi over 6 right here. And then this angle would be negative 5 pi over 6. So pi over 6 is 30 degrees right here. So then we calculate the various things the same way as we do here, but with some care as to the sign. That is, the x value is negative because we're on the negative side of the x-axis, and the y value is also negative, so they're both negative. Okay, so you have to watch out for that very carefully to figure out what the values are. For example, let's say, what is the cosine of this angle? The cosine will be adjacent over hypotenuse, which cosine of 30 degrees would, remember, to calculate an angle that's bigger than 90 degrees, the sine and cosine, etc., is calculated by what's left. This is called the reference angle, and figure out the sine and cosine of this thing. But then you have to follow whether it's positive or negative, though. For example, the pi over 6, the sine of pi over 6, that is sine of 30 degrees, is 1 over 2. But is it positive or negative? In this case, sine is, this value is negative. Okay, so the 1 is negative. The hypotenuse, we don't care what sign it is. So it's that is, the sine of this value is going to be a negative 1/2. As is shown here, where sine, yep, is minus 1/2. And then if you consider what is the tangent, now the tangent of 30 degrees, or pi over 6, is opposite divided by adjacent, okay, which is 1 over square root of 3, which is fine. But is it positive or negative? Is the 1 is negative because it's the y value is negative, but the x value is also negative. So we have minus 1 divided by minus square root of 3, and we end up with a positive value. That's why it shows the tangent value end up being positive, and that sort of thing. So please do example 3 yourself, all 6 values. The tricky part is mostly deciding whether we have a positive or negative value. And since both x and y are negative here, all your values are going to be negative except the tangent and the cotangent, because the tangent and cotangent are dependent on x divided by y, or y divided by x, or something, so that the negative signs canceled out. Everything else, however, is going to be negative. So then, so that's that. And let's look at the next thing is we talk about whether the trigonometric functions are even or odd. The even function is a function such that is f of minus x equal to f of x, like this. Okay, that is, if you stick a minus value in there, it's the same as if you have a positive value in there. And so it's such as, for example, x squared. Y equal to x squared is a classic example of an even function. That's because x got squared, so it doesn't matter if x is positive or negative, it gets squared and give you the same result, and that's why that's the same. Now, similarly, there is from algebra, we have learned that there's something called an odd function, where f of minus x is going to be minus of f of x. That is, the negative sign comes out. And the classic example, look at the next page, will be y equal to x to the power 3. That is a classic odd function. That is, if you stick a negative sign in here, okay, it ends up being the minus sign end up being able to come out. Let's see, where does it say that? I think it's on the previous page. Yeah, it is. See, that is f equal to x cubed satisfies this requirement. That is f of minus x equal to minus f of x. Whereas the even function says that f of minus x is just f of x. That is on top right here. This is on page, we're still on page 740, I think. Yep. So those are the different things of the qualities. Now, having said that, then let's consider sine and cosine and all these things and see if they're even or odd. That is not as big a deal, really. I mean, whether a function is even or odd, but it's something worth mentioning, I suppose, that you will very soon find out by looking. Let's look at the following page. I'm now on page 741. So on page 741, we have noticed that the sine function, if you were to check it, the sine function, you will notice that by checking the angle t and the angle negative t, then you find out the sine function is an odd function, because sine of t equals to sine of minus t equal to minus sine of t. And then the cosine function is an even function in the sense that we can stick a negative sign in there and it doesn't change the answer. Okay, cosine t and cosine minus t both equal to x, that sort of thing. And then tangent is also an odd function, and the other three we really don't care. Okay, but anyway, there is such a thing that. But the summary at the bottom of the page is that only cosine and the one that flips over cosine, which is secant, are the even functions, whereas every other thing are all odd functions. And yeah, but anyway, so that is that. And so knowing that, then please do example 4 yourself, okay? Way big, where we said that if, please do example 4 yourself, that's all. Then, so let's look at some identities, basic identities. That is, first thing on the following page, I'm now on page 742, the fundamental identities is, the first thing we need to remember is that tangent is the same as sine over cosine. Now, if you look at the definition of sine, which is opposite over a hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you take sine divided by cosine, then the hypotenuse will get canceled out, and all you got is opposite divided adjacent, which is why tangent is equal to sine over cosine. Okay, and that's all there is to this. So yeah, so I suppose I can write down one more thing here. That is tangent, well, I'll do that later. But anyway, tangent is equal to sine over cosine, which is also what we have drawn before. See, this line on the unit circle, this is cosine, and that is sine. And then tangent is opposite divided by hypotenuse, which is sine over cosine. So that is that. And with that, let's do example 5 after I clean off the board. All right, so let's look at page 742, example 5, part A. We have sine 45 is given to us is square root of 2 over 2. Cosine 45 is square root of 2 over 2. Notice they're the same, or same value. And what do they want? They want you to calculate tangent of 45 degrees. Now, we know that tangent is opposite over hypotenuse. It's also equal to sine over cosine. So tangent is just the sine over cosine, and this happens to be the same thing. Therefore, the tangent of 45 equals to 1. Okay, and if you flip over to the other side, that is what it says. Tangent of 45 equals to 1. So let's look at part B. Now, sine of this thing is equal to 1/2. Cosine of this thing is equal to minus square root of 3 over 2. Evaluate secant of this. Now, secant is equal to 1 over cosine. So we'll just flip cosine around. What is cosine again? Minus square root of 3 over 2. So the secant will be minus 2 over square root of 3. That's it. Then that is the answer. Okay, and that is what it says, except it rationalized the denominator by multiplying a square root of 3 on top and bottom, but otherwise it is the correct answer. So that's that. So next, let's look at example 6 on the following page. Now, example 6 on page 743 says we need to simplify secant over tangent. Now, to do this type of thing, what we do is secant is equal to 1 over cosine, so we'll write that down. 1 over cosine t, says right here. See, secant is 1 over cosine. And then tangent is tangent is sine over cosine. Okay, it's opposite divided by adjacent. So tangent is sine over cosine, sine t over cosine t. And then we do something here. Now, to do this, this is the division line. To divide by a fraction is to invert and multiply. So we'll do this. Cosine of t, that's the top, the top stays, okay? We'll invert and multiply the bottom, which that gives it cosine t divided by sine t. And then this will be equal to, so the answer is 1 over, right over here. The answer is cosine t's get canceled out, and we have 1 over sine t, which is the answer. And you can also write down, being the 1 over sine t is cosecant, okay? Cosecant is flipping sine around. And so we can also write down this as the cosecant of t. Yep, and that is what the book says. Okay, so that's example 6. Now in the last section we have stated that a sine squared plus cosine squared equals to 1. That's the Pythagoras theorem in trigonometric form. Okay, because this is cosine t and that's sine t, and then this is the unit circle, so it has a length of 1, and therefore this is on the unit circle. So cosine squared, sine squared plus cosine squared equals to 1, and you should remember that right along Pythagoras theorem because it's the same thing. Now we have there are other ways of expressing that though. So if you write down, let's write over here. Okay, so write down the original one says sine squared t. Remember, this means the entire sine t is being squared, plus cosine squared t. This equals to 1. Okay, and then we can divide everything by sine squared, like this. Okay, we'll divide by sine squared t. And why are we doing that? It's just a manipulation that we do sometimes. There's not much. Well, anyway, it's a thing, so we're gonna do it. Okay, and it's a tradition to do this. So once you do the division, so this is the original thing: sine squared plus cosine squared equals to 1. But what if we divide everything by sine squared of t? Then this becomes 1, okay? And then this is cosine over sine. Now cosine over sine, tangent is sine over cosine. So cosine over sine is flipping tangent around, which is a cotangent. So this part is called a cotangent, cotangent squared of t. That equals to 1 over sine squared. What is 1 over sine? 1 over sine is cosecant, okay? And so we have this equals to, what am I talking about? Cosecant. I just said cosecant. So this equals cosecant CSC t squared, okay? Again, remember this square means the whole thing is being squared. But we write it this way to save time and energy and stuff. And so this is another way of saying the Pythagoras theorem. It's not used as much. Why is there an equal sign here? It's supposed to be plus. So there's the plus, okay? And let's have a plus here. That's better. And similarly to this one, what if we divide not by sine but cosine? If we were to divide by cosine, then this becomes sine over cosine, which is tangent. So this part will become tangent squared t, and then plus, and again, if we were dividing by cosine, this cosine over cosine becomes 1, and then this will be 1 over cosine, and 1 over cosine is secant. So this part, it becomes secant squared. That's the other formula. These two formulas are not used near as often. Well, it's hardly ever used at all. Let's put it this way. But we present it because it's a tradition to do so. Okay. So, but the only thing you really need to memorize is sine squared plus cosine squared equals to 1, which is another way of saying a squared plus b squared equals to c squared, Pythagoras theorem, which you must never, ever forget. Okay, so that is the end of this page, and let's look at the next example on the following page, and to do something. Okay, now example 7 says if cosine of t is 12 over 13, all right, and then t is in quadrant 4, and then we're supposed to find out what all the other trigonometric functions are. So here's a graph that your book draw. The cosine t is 12 over 13, and t is in quadrant 4. That means t is down here. Okay, the quadrants counts this way: quadrant 1, and quadrant 2, quadrant 3 down here, and quadrant 4 is the last one. So it goes in a counterclockwise method. Well, anyway, quadrant 4 is in that corner. Okay, and what are we gonna do about that? So we are going to, calculate it, okay? So to do that, first we need to pay attention to the graph. Like in other words, who's positive and who's negative. That's the most important point. And so draw this thing, it's down here. So this value is 12 over What's 12 over 13? Oh, cosine t is 12 over 13, okay? So that's 12 over 13, and this is 1, and what's that thing? Well, we're going to use the Pythagoras theorem to figure out what this length is, because we need it to do all our trigonometric measurements. So let's do that. By the Pythagoras theorem, let's call this thing, I don't know, y or something. Or actually, we don't need to call it y. We'll just figure out what it is. The value of this length here, by the Pythagoras theorem, is 1 squared minus 12 over 13 squared. And then we'll take the square root. And that should be this thing, right? Because this squared plus that squared equals to 1. So we'll just quickly do the thing. Give me a second here. Where's my calculator? All right, I got it. Here's my calculator. Let's turn it on. We'll do 1 minus 12 over 13 squared. So let's do that. 12 divided by 13, close parentheses, squared. Okay, can you see it okay? I hope so. And so that is equal to something. That's 25 over 169. And so we'll take the square root. 25 is the square of 5, of course. So this part is 5 over 169 is the square of 13. So that's that. And that's just something I memorized. If you don't remember that, then I just use the calculator to do the square root of 169. In fact, I think I'll do that right now to show you. Here's the square root button. 169. Okay, that is equal to 13. See? So that's where I got this. So then this side is 5 over 13. And with that, we can we know everything about this angle. The angle is this one right here. Okay, that's the angle T. And the only part that we should notice is that while x value is positive here, the y value is negative. So watch out for that. What that means, everything that has to do with y, such as sine, which is the opposite divided by hypotenuse, is going to have a negative value. So we can just look at this and read it out loud. First, what is the sine of t? Sine of t is this one divided by this. Okay, we just have to pay attention. Being that these things, we'll call one 13 over 13. That way we don't have to worry about the 13 so much. Okay, so then the ratios are all, we only have to worry about the numerator for the ratios. That is, let me show you, okay? What is sine of t? Sine of t will be 5 over opposite divided by hypotenuse, 5 over 13. Okay, these, because we're just talking about ratios, and they have the same, all three things have the same denominator, so it cancels out. So sine of t is negative 5 over 13 because the y value is negative. So that should be that. Where is it? Yep, the sine value is minus 5 over 13. Cosine of t is 12 over 13, positive, okay, because the x value is positive. Does it say that anywhere? Where's cosine? I'm not seeing the cosine on this page. Did they forget to do the cosine? Whatever. Doesn't matter, okay? The cosine is 12 over 13. And the tangent is 5 negative because negative over positive, so the tangent is negative. Tangent is negative 5 over 13. Sorry, 5 over 12 because tangent is opposite divided by adjacent. So it's a negative 5 over 12. And then secant is the other cosine, okay? Which means we already did the cosine. So please finish the secant, cosecant, and cotangent yourself. They're just flipping the other three around that we already did. Now, where did they do cosine? Oh, cosine's already given. That's why. Okay, so that's that. So please finish the example 7 yourself. And then let's move on to example, the next page, so page 745. Now 700, and there's a matter of the period. The period of a trigonometric function is where the function has the same value after you've gone through a certain cycle. For example, let's say we have this angle here, okay, which is t, and we can calculate sine of t, cosine of t. What if we go here and go clear around and then back here again? So the angle becomes 2 pi plus t. Now 2 pi plus t has the same value of sine, cosine, and all that stuff, okay, because that only depends on where the thing ended. So as a result, the trigonometric functions have a period that was in such a way that f of x plus p, the period, which is 2 pi, okay, is the same as f of x. And that is, for example, sine of x plus 2 pi is equal to sine of x. Cosine of x plus 2 pi is also sine of x, is equal to cosine of x. That is, after it spins through 2 pi, it lands in the same spot. So the sine, cosine, all that are the same. Now, specifically, the tangent has a quality that its period is only pi. That's because tangent is depending on a different set of values, so that by the time it got through pi, it's already repeating itself. Okay, the tangent value is positive up here and down here. So tangent and also cotangent, which is just flipping tangent around, and they both have a smaller period that's only half as big. But anyway, that's a thing. Now, let's see, what are we doing here? Example 8, find the values. Yeah. Anyway, so please do example 8 yourself. That's the same thing we've been doing. And it's it shouldn't take too long to do this. One's nothing. Okay, so please do example 8, and let's flip on to the next page. What's this? And look at example 9, please. Example 9 on the following page. I'm on page 746, example 9, where it says we have sine value equals to this thing, square root of 3 over 2. Except it's negative, and cosine is 1/2. What are the other values? Okay, and then the other values, once you have sine and cosine, you can get the other values. For example, secant is we now have sine and cosine. Okay, that means we also know secant and secant here and cosecant, because they're just flipping sine and cosine over, right? And then what is tangent? Tangent is sine over cosine. It says right here, tangent equal to, just take the sine divided by cosine and you get tangent. So that's taken care of. And then the last one, cotangent, is just flipping tangent around. So all six functions are taken care of once you know. The other 4 functions are taken care of once you know what sine and cosine are. And that is example 9. Okay. So the last thing we want to talk about is let's see, after at the bottom of the page 746, and if you look towards the bottom, it says that the cosecant. How do you calculate cosecant, secant, and cotangent? The book says down here, there may not be any keys that says cosecant. It's not a matter of there may not, there will not be. Okay, I've never seen a calculator with cosecant. Why would you want that? That would be ridiculous. Okay, like my calculator doesn't have it. See, this thing, and there's no cosecant here. If you were to, okay, let me cover my. Let's see if it'll focus. Yeah, see, there is no such thing. And this is just a cheap calculator. But I also have an expensive one, and this one doesn't have either. This is a TI-84, and look at that. There is no. It's not going to have cosecant. Why would you want that? All you need to do is just do sine and then flip it around. So, yeah, no calculator would ever have cosecant. That would be ridiculous. So anyway, so example 10 is completely comical because it tells you to enter look at example 10 on the following page. Okay, it says that we need to figure out what the cosecant of 5 pi over 7 is. Well, And what does it want you to do? It wants you to type in 5 times pi over 7, then push the button sign. Don't do that, okay? Because now why do they do that? Because, and I mean, why would you be pushing the sign button afterwards? That was true back in my day when I was studying trigonometry many years ago. Okay, and when calculators were old, this calculator is already old and it doesn't do that. I mean, if you need to do what sine is, you just type it in. You don't have to do that nonsense. And back in the day when calculator technology was more limited, you have to type in the angle first, then push the sine button. For example, if you want to type in sine 30 degrees, right now all we have to do is just push sine and then 30, making sure that you're in degree mode, and then push enter. But back in the day, you have to push 30, then push sine, which is not as intuitive and much more difficult to manipulate. And I can't believe that the book is still teaching you to use a calculator in the way that it was done, I don't know, zillion years ago. I mean, how old is the guy who made up this example that he doesn't even know that calculators don't do that anymore? Okay, so please don't do that. And to evaluate, how do we evaluate cosecant of 5 pi over 7? Well, we will do cosecant is 1 over sine. So what we're going to do to evaluate cosecant anything, we'll do, so let's say we're trying to do CSC cosecant of, what was it, 5 pi over 7? All right, 5 pi over 7. So that is equal to 1 over sine of cosecant is 1 over sine. Right here, okay, cosecant is 1 over sine. So we'll just type in 1 over sine 5 pi over 7. That's all. Okay, I mean, why would you purposefully design a special button in the calculator just to do that? That doesn't make any sense. So no calculator would ever do such a thing. And so let's do this. Okay, how would we do this? And so here we are. My calculator is in radian mode. And it needs to be in, make sure your calculator is in the radian mode before you do this. So 1 divided by, we'll put parentheses here just to be safe, sine of 5 pi divided by 7, and then close parentheses, a couple of close parentheses, and that equals to 1.279. Which is what the book says. Okay, that's all there is to it. And notice that, and even this is a cheap calculator. I mean, years ago, I bought this calculator when my son was taking trigonometries, or in high school. That's how many years ago. And yeah, look at that. You don't need to push sine after the entry. You gotta be kidding. How old is that? And anyway, so this is how you type in trigonometric functions into the calculator. And that's true if you're using TI's something as well. And yeah, I'm not going to use the TI calculator in this course, or in any course really, and because I don't like them very much. They are they're highly tedious and annoying. But anyway, but of course you feel free to use one if you prefer, or if you're required to do it. But if you do, make sure you study the manual carefully and know how to do all the stuff that you're supposed to do. You know, all the trigonometric functions, how to enter them, how to graph. Anyway, that is a giant headache. And I'm not going to talk about it anymore. So we have come to the end of this section. For homework, please do, this is on page 748. Do all the examples except example 10. There's no need to do that. And then do that chart on page 739 that I mentioned. Okay, the chart that gives you all the values of the standard angles. That is, by using these two triangles as references, should be able to go over it fairly quickly. And then the homework, there'll be quite a bit of homework, not as many as last time, but still quite a bit. But the homework most of them should be quite straightforward, and you can do them within a few minutes, each one. So for homework, please do problems. Let me see, wait, give me a second here. So for homework on page 748, please do problems 13, 15, 19, 23, 25, 29, 31, 33, 37, 39, 43, 45, 47, 51, 53, 55, 57, 59, 61, 63, 65, and 71. And I won't be going over them because they are all quite short, I think. And if you just go over all the examples carefully yourself, and you shouldn't have any trouble with it. And of course, as with all homework, make sure you check the answer at the back of your book, so to make sure that you got everything right. And the same as doing examples, okay? It's important to check to make sure that you didn't do anything wrong, and if you do, figure out where you did wrong. And that should mark the end of this section.